Okay, I can see Mr. Chaudier.
Thank you. All right, you guys are late. What's up, Haley?
Who's late?
Not so much. What's up?
No. Your shirt's not tucked in. You don't have a belt on. Tuck your shirt in. All right, listen up. I need to switch a couple people. I need Nathan. Grab your stuff. You're switching with Ari. I need Sierra. Grab your stuff. You're switching here. And I need you to swap with Piper.
That's in the front.
No. Hey, quick speech. Graded the, what do we take? A test or quiz? Oh, test, right. I finally got graded. Hey, here's the deal. As a class, we're doing great. As a class, we're doing great, right? The results on the test were exactly what I expected. There's a couple people that I'm concerned with, right? Algebra is tough, and we're doing the easy stuff right now. We haven't done technically anything new. Everything that we've done so far was a review from pre-algebra, including today, right? We're about to get to the new stuff next week. But from, I don't know, next week onward, every single day, it's brand new stuff. I mean, brand new stuff, right? The ability of you to quickly adapt to new stuff, we're going to find out where that lies. Some of you, since what you showed me in the previous, 2 chapters or 2.5 chapters, not where we need to be, okay? But as a class, and you'll see when I hand out the test at the end of class, I mean, if you got a C or above, you're where you need to be. If you got a D or below, we're definitely not where we need to be. And it's only going to get tough this year, okay? All right, homework, any questions? All right, I'm just going to collect it today. Just collect it today. Almost all Fridays, unless the short class, I will collect homework. All right, and for those of you that are sitting here and you got an AMI class and you're like, when is it going to get hard? It's going to get hard. It's going to get challenging. It's just not today, right? But trust me, if you ever doubt me, take your book right now and open it up to somewhere around the middle, look at it and tell me if you can do it right now, right? It is going to be new stuff, right? But we got to get some background stuff out of the way first. Chapter 1 and Chapter 2, and this is in most math books, maybe not geometry. Chapter 1 and Chapter 2 of most math books will have material that you've seen before. All right, homework tonight or over the weekend is as follows.
3-step equation.
No, today's just 2 steps. 2 steps. We'll do 3 steps Monday. Well, we'll do more than 3 steps on Monday. All right. I moved some people around. 2 reasons. One, there was a social dynamic, especially in that corner over there, that was becoming unacademic, right? It's easy, especially at your age, to fall into the, I don't know, the kids around me are kind of messing around. I'll mess around as well, too. And the same thing was going back in this corner. And I got to stop that before we get too further into the book. And one of the reasons that is, one, the dynamics of this class. We got some really sharp kids in this class right now. And they're kind of spread out. They're not like grouped together. And then we got some kids that are average, right? And we got some kids that are struggling at algebra. I want to make sure that we have a little bit more of a heterogeneous distribution. You've heard that word before? Yes. Homogeneous means everything's the same, right? Oh, the smart kids are sitting over here, the average kids are sitting here, and the kids that struggle are sitting over there. Heterogeneous, and we're kind of like mixed together. Okay? Right? You get 3 smart kids that already can figure this out, and they're going to not pay any attention to the teacher because they already got it figured out. Right? And that'll be the case today as well too. All right, enough of that. Let's get going at 2-step. It still calls it transforming equations. It's a 2-step equation. It's going to take us 2 steps to get the answer. You got a good pre-algebra teacher, you already know how to do this, but here's where we get to problems where you literally don't know the answers by looking at the problem. You actually got to do the algebra steps. Well, luckily, we've already spent 2 days learning the correct way of doing algebra steps. We just need to now apply that to two-step equations. So here we go. No, I'm not going to make you write this down, but I do want you to remember, you know you're done when the variable is by itself. You know to get rid of things by doing inverse operations, right? You know that these are the 4 things I'm going to say when I say to solve an algebra equation. Hey, where is the variable? Left or right side? What's attached to it, right? Because it's not, I mean, what you're trying to get rid of the things that are attached to the variable. We ask ourselves how they're attached, and we do the inverse operations. Every single time someone goes over an algebra problem, that's what I will say. All right, today's hint is this. Check it out. Chris, where's the variable? Left or right side?
It's on the left side.
Okay, look at the left side and just the left side. What 2 numbers are attached to it? 3 and 4 are attached to it. 3 is attached by, and 4 is attached by. Good job, Chris. You're growing your voice. All right? Chris, if you had a choice in life of either multiplying or adding or subtracting, which one would you choose? This is why almost always, today's hint, almost always, I'll show you the one exception at the end of class. Almost always, you will always get rid of what first? The easiest one, which is adding or subtracting. Let me point out this, and I'll prove to you why it's easiest. Hey, how is 3 attached to n?
Through addition. No, wait, sorry, subtraction. No, wait. So we're still doing adding.
How is 3 attached to n? How do we get rid of multiplication, everyone? So if you decide to get rid of the 3 first, guess what you got to do to everything up there? I got to divide it by 3. Well, I can divide 3 by 3. That's pretty easy, but now you're dividing 4 by 3 and 14 by 3. You see that mess? You want to divide 14 by 3? Heck no. So today's hint, almost always, if it ever looks like this, we're going to get rid of addition or subtraction first. That's today's hint. So how is the 4 attached to n? How do we get rid of subtraction? What are we going to add to both sides? So we're going to add 4 to both sides. That's today's hint. Why is this not clicking? We're going to add 4 to both sides, right? Because we have 2 options here. So for a 2-step equation, and it should say almost always get rid of addition and subtraction first. There's one example, and it will look like, it will be in box 6 and 7. It'll be the one time that you will not get rid of addition and subtraction first. Well, we're not at the box 6 or 7 yet. Okay, we good? Today's hint?
Yep.
All right, let's apply it. So what are we going to do to both sides? Add 4 to both sides. I'm going to get rid of the minus 4. You don't have to rewrite it like I did. We're going to get rid of the minus 4 by adding 4. What's 14 plus 4? Do I need to write this 0 any longer right here? This isn't canceling. It just turns into 0. So I'm not going to write that 0 anymore. How do we get rid of the 3? And notice that this 18 is divisible by 3. That's why it turns into a friendly problem if you get rid of addition and subtraction first. If you decide to divide by 3 right from the very start, you're guaranteed to get to the right answer, but you got to deal with an ugly fraction. Don't deal with an ugly fraction. Get rid of addition and subtraction first. What's 18 divided by 3? Somebody?
What? 6.
What's 3 divided by 3?
1.
1. That is your canceling. That slash through this. That slash through the 3's, that's your canceling. Right? Okay, questions? Now maybe it makes more sense to do a check step, right? So a check step is this. Oh, and I was going to show you what happens. This is the ugliness, right? If you decide to divide by 3, right? 14 divided by 3, I don't want to do that, right? If I did, however, 3 divided by 3 is 1, but minus 4 divided by 3 is still minus 4 divided by 3. You're dealing with fractions now. Nobody wants to do that. How will we get rid of negative 4/3? How is 4/3 attached to n? Subtraction. So how do we get rid of a subtraction?
Addition.
We would have to add 4. I'm doing all this stuff with fractions. Add 4/3 to both sides. 14 plus 4 is 18. We get 18/3, which is still the same answer. But nobody wants to deal with this ugliness. This was nice and pretty over here. Don't get rid of multiplication or division first. The check step, we're claiming the answer is 6. Let's throw 6 back into the equation. What's 3 times 6? Minus 4. Chris, are you paying attention? No, you weren't. All right. It's 14. Okay, that's your check step. We throw in the 6 for the end value. 18 minus 4 is 14. Check, it works out. Okay. One more time. Hey, what 2 numbers do I need to get rid of here? What 2 numbers do I need to get rid of? Nathan? It's not a 5. It's not a 5. Negative 5 and 35. So what was my suggestion? Which one should we get rid of? Okay. We're going to get rid of the one that's attached by addition or subtraction first. Let's get rid of 35. How do you get rid of that 35? Both sides, right? So I'm going to, you don't need to rewrite it like I'm doing here. I'm going to get rid of 35. You can do that, Nathan, really quickly in your head. Okay. Last step. Both sides by? Can you do that one in your head or no? Okay, what's a positive divided by a negative? Okay, it's negative 20. Cool? Brand new for anyone. It would only be new kids, right?
Me. It's brand new.
No, it's not. All right, let's do one together. What is this, box 3? Here we go. Tristan, left or right side are we working on? Let's look at the left side. Tristan, what are the 2 numbers we need to get rid of? We never get rid of x. So what 2 numbers am I getting rid of? Okay, which one you want to get rid of first? Okay, how do you get rid of it? Both sides, right? So let's subtract both sides. 3. Can you do that one in your head? 45, okay. So last step would be, can you do that one in your head? Okay, 45 divided by 15 is 3. Okay. Yes? Right. All right. Check step. We're claiming the answer is 3. Well, let's throw it back in. No, you don't need to always do a check step. It's just if you have the time, you can check. 15 times 3 is 45, plus 3 is in fact 48. It works out. Okay. All right, you got 3 problems in front of you. I will give you a 20-second head start, and I'll walk you through each one. I'll give you a 20-second head start. If you need help, wait for me to walk you through. Rylan, you got this stuff? You sure? On your test, you didn't have this stuff. And you told me every day you got this stuff. So I'm going to hit you up every day. You got this? Okay. Yeah.
I need help.
Okay.
I'm joking.
I don't know now if you're joking or not after grading your test.
Ooh.
Oh, dude, come. Jeez, that is brutal.
My test was afterwards.
I was debating whether to have a personal talk with you outside
Bro.
about life in general, but I decided not to.
My life is not okay right now.
Yeah, but we can have a little bubble of math that you're good at, right? As long as you pay attention. I know you. I grade your stuff all the time. I know you're good at math, right? But I do know that when you read a book in class and don't pay attention, that things don't go well. Yes. Sure. All right, here we go. I said 20-second head start. Here we go. Chris, first one. Which one am I going to get rid of? The 7 or the 10?
10.
All right. Are you doing this with your paper right now? Okay. So what are we going to do? Subtract 10 from both sides or add 10 from both sides?
We're gonna subtract. No, we're gonna add.
We are going to add 10 to both sides. So if I add 10 to both sides, I don't have the steps here. I'm going to add 10 to both sides. I get 14, so I get 7n equals 14. Then what, Chris?
We do 7 times 14. No, sorry, we do 7 divided by 14. No, wait.
I'm not saying anything.
Wait, what? Hold on.
Chris,
Zero.
every single time you ask yourself, where's the variable, what's attached, how it's attached to the inverse?
Okay, so we do 7 divided by Yes.
No, I think you in your mind you think you're saying the correct thing, but your words you're choosing are not correct. But I think in your mind you know what you're doing. Where is the variable? What's attached?
7.
How is it attached?
Multiplication.
Do the inverse.
Division.
By which number are you trying to get rid of?
14.
So if I get rid of 14, that's the answer?
No.
So which number do I need to get rid of?
7.
How do you get rid of that 7? So that's what we were all waiting for you to say. So what are we going to do to both sides?
5.
By,
7.
okay, so if you divide both sides by 7, you get n equals 2.
Yes.
Okay. Mike, you got the answer to the middle one? What do you got? 8. I don't believe it's 8. How can I prove it's wrong? How can I prove it's wrong?
That's be a variable attached to it.
No, okay, no. Well, let's just say, for instance, he said n equals 8. I don't believe it's right. How can I prove him wrong? Check step. What's 4 times 8? 4 times 8. He's claiming that 8's the answer. 4 times 8
32.
minus 20 is
12.
not 16. That's how I know he got it wrong. See how the check step works? When you do algebra, especially next week, you're going to be doing 4 and 5 steps. You're going to get to an answer. That's the thing about algebra. You always get to an answer, but it might be the wrong answer. Yeah? 9. Okay, let's see. 4 times 9 is minus 20. And that's how I know that 9 is the right answer. So n equals 9. Yeah?
It's 3.
I don't believe you. 2 times negative 2 times 3 is
6.
it's not 6. Negative 2 times 3 is negative 6 minus 1 is negative 6, not 5. That's how I know he's wrong. Check step. You will get to an answer every single time. It just might be a wrong answer. So what are you claiming now?
Negatives.
Negative 2 times negative 3 is
Negatives.
negative times a negative. Positive 6. 6 minus 1 is 5. That's how now I know you have the right answer. I'm not saying you got to do a check step, but you can do a check step. I had 2 people literally tell me the wrong answer, right? And I was able to quickly tell, not by doing algebra, by evaluation, that it was wrong. Cool? All right. We got to do more practice. We need to get to where we're all getting this right. All right. Once again, 20-second head start. Make sure you're showing me all the steps, unless you were just writing the answer because you didn't do it. But show me all the steps. Okay, what's your first step?
I can't remember if you.
What number are we trying to get rid of?
4.
Okay, you either get rid of the 4 or the 6, which is the easiest number to get rid of.
6.
So let's how to get rid of plus 6.
Minus.
So minus 6 underneath the 6. Minus 6. And then on the other side, minus 6. So whatever you do to one side, and you just do a division bar. The bar for addition and subtraction will go underneath the 6. So as soon as you wrote that you had 6, and then you put minus 6 on it, that means 6 divided by negative 6. This means 6 minus 6. Did you get all 3 of those right, Sarah? Okay, draw a horizontal bar. There you go. Now let's do the math. 18 minus 6? 12. Right, 12. Yep. And put the equal sign. Oh no. See the equal sign? It just drops straight down. And drop what's left? 4n. And what are you trying to get rid of now? Attach. What? How do we get rid of multiplication? Divide both sides by 4. All right, here we go. Let's see somebody else. Julie, first one. What do you got? 3. Let's see. 4 times 3 is 12 plus 6, 18. Perfect job. Good job.
Oh no.
Yeah? Porter, you got the middle one? Oh, yeah,
N equals 10.
10. 3 times 10 is 30. 30 plus 20 is not negative 10. I know he got that one wrong. The most common error in math, in algebra, is when you drop a negative. So maybe it's not 10, maybe it's 3 times negative 10 is negative 30. Negative 30 plus 10 is in fact negative 20. Oh, sorry. Negative 30 plus 20 is a negative 10. I'm all confused. All right. Yes.
This is the last one for you.
Is it 3? Let's see. Negative 8 times 3 is negative 24. Negative 24 plus 1 is negative 31. You got, Sophia? Negative 4. Negative 8 times negative 4 is a positive 32. Plus 1 is 33, not negative 31. So it can't be that either. We better take a look at this one. All right, Sophia, first step, what did you do? Oh, well, tell me what did you do, and I'll tell you if you can do it or not.
Put 8 out in little dots and then connect it on the pen.
I mean, you did like a physical method? You do dots like this?
And then divide it.
I'm going to tell you this. For these simple problems, that works great. It ain't going to work past 2 steps. It's going to be way too complicated to do a physical model. So you.
That was the only one I got wrong.
No, I know, but I'm saying. Tell me how many dots. Here's your prop. That's next week, by the way. Tell me how many dots. See what I mean? I don't. You can't do this with a dot model. Well, okay, maybe some genius could, but we're not going to be able to do this quickly with a dot model. So I need you to do it the way I'm showing you, because next week by Tuesday, that's a Tuesday problem I just showed you, by the way. So what should be the first thing you do? Either getting rid of negative 8 or positive 1. Which one? Okay, then you got to divide everything by negative 8. You're dividing 1 by negative 8. We don't want any of that mess. So let's get rid of 1. How do you get rid of 1? Subtract 1 both sides. What's negative 31 minus 1? What? Negative 32. Then we both sides by negative 8.
Oh.
Therefore, n equals. What times 8 is 32?
4.
Okay, that's why n is equal to 4.
Oh. Okay.
So there's nothing wrong with the physical model. And the physical model is pretty cool, especially, and she's pretty good at word problems as well, too. The dot model, right, you're drawing a picture of the algebra problem, is how we introduce algebra concept to lots of kids. You have different programs. It's probably how you learned algebra as well, too. But we got to transition from those physical model into the algebraic solving steps, because we're getting the really complicated ones next week. All right. So I said that we're almost always going to add or subtract. Chris, put it away. If you have an 8 in class, I'm not going to call you out. Right? All right, these are the special ones. You see it? All right. How many numbers do I need to get rid of here? Well, I can clearly see one number I need to get rid of. What's that number? Turns out there's another number right here. There's a 1 right there, so negative 1x. So there's actually 2 numbers. Which is the easiest number for I need to get rid of? Negative what? If we get rid of negative 1, we're going to do what to everything? Okay, this is the one time, pun intended, this is the one time where you actually could divide everything by 1 and not wind up with ugly fractions. Once again, I'm going to stick to my guns and say, with one exception, never get rid of multiplication division first. Right? This is a suggestion. I didn't say it's a rule. I would always get rid of the addition subtraction first. So get rid of the, I would get rid of the negative 5 first. It's a pretty good rule to follow, but it is a suggestion. It's not a requirement. And the reason is, if this was a negative 2, Well, then she's saying let's divide everything by a -2, and you get these ugly fractions. Let's not deal with ugly fractions. Let's get rid of the -5. So, Brandy, what do we do to both sides? Let's add 5 to both sides. So if we add 5 to both sides, 17 and 5 is somebody 22. Now, do you remember this from the other day? When we did one steps, it'll look like this. There's two interpretations. The first one says there's a -1 right here. So let's either divide or multiply by -1. The second interpretation is that if you have a negative variable equals something else, the answer will just be the opposite. Either one works, right? You can multiply both sides by -1. A negative times a negative is a, that's why x would equal -22. The second interpretation is this. If you ever get down to this, everybody open your eyes, look at the board. If it ever looks like this, negative variable number, we just write the opposite of both sides. What's the opposite of -x? What's the opposite of 22? I don't want you to say, well, I just make the other side negative. That's not really true. I just write the opposite of both sides. By the end of this year, no one is going to be multiplying through by -1. They're just going to say, oh, it's just the opposite. But mathematically, this is what allows you to say that the answer is the opposite. You could also divide by. Hey, you remember doing these yesterday? This was the homework, right? So what do you want to do first? Get rid of division or get rid of subtraction? Let's get rid of subtraction. How do you get rid of -13? Okay, both sides. Okay, 12 and 13.
14.
12 and 13, Nathan? Nathan? I don't know what I was thinking, but I couldn't say the words.
11. Wait, wow.
Well, he wouldn't be right if it was subtraction. He needs to take, don't cover up your mouth and your nose. You're not getting enough oxygen.
15.
15, thank you. Nathan, do you remember how we get rid of this 3? How is the 3 attached to B? How do we get rid of division? We're going to multiply both sides by the number we're trying to get rid of, which in this case is 3. So I'm not going to put the 3 down here. 3 times 3 is 9. I'm going to put 3 in the numerator because 3 divided by 3 is
1.
The 3's cancel, and you're just left with a B equals whatever 15 times 3 is, which is 45. Yes? All right. Let's do one together, Bucks. 6B. 6 problem. Josie, are we going to get rid of the 4 or the -10?
The -10.
That's what I would suggest. So, how do you get rid of -10?
+10.
Both sides. No, you don't need to rewrite it like that. I'm just pointing to the thing I'm getting rid of first. You're frowning. Why?
I'm really confused.
On.
This is wrong.
Okay, so do you see that there's 2 numbers I need to get rid of? What are the 2 numbers? Which one is the easiest to get rid of? That's why we're adding 10 to both sides. This arrow, I was just for kids, it's like, where are you working? I'm working right here. All I did was rewrite the problem and then add 10 to both sides. Yeah? -6 and 10? Same or different signs? So is that add or subtract? So subtract. More positives, more negatives. It's freaking magic, right? I say those words and magic happens. It's crazy. Why don't you have those words tattooed to your armor? I mean, don't do that, please. Those are the words. You got to have those in front of your face, Kaylee, all the time. Because all I do is say those words and you get it right. And I'm not doing the math for it. You're saying everything. So she said +4. All right, keep going. What do we need to get rid of now? Okay, how's it attached? So we're going to both sides by their 4. 4's cancel, and you're left with t equals somebody.
One.
Wait, what's going on?
Look at the problem.
T equals 16.
No.
Yes.
Wait, yes. Yes.
You're scaring me, Ron.
Yes.
All right. Hey, we got like 3 minutes. I can do this in 3 minutes. All right, watch the board.
I hate my
There's only one time where you're not going to get rid of addition subtraction first. You ready? All right. One exception. I always want you to get rid of addition subtraction first. Josie, pay attention. This is what it looks like. How many numbers do I need to get rid of?
2.
It's still 2 numbers, so it's still a 2-step equation. The 7 is attached through, and the 3 is attached through. Okay, up until this one case, I said get rid of addition subtraction first. This is the only time that you're going to get rid of division first. The only time. You'll see why here in a second. Okay, how's the 3 attached to x? How do we get rid of division? Let's multiply both sides, therefore, by. So I'm going to multiply both sides by 3. What happens to the 3's? This is why you do that first. If you decide that we're going to add 7 to both sides, guess what would happen? Is that really a 7? It's not. Guess what it really is? It's -7/3. You would have to add -7/3 to both sides. Hey, you want to add -7/3 to 12? Heck no, not in my universe. You have to get common denominators, right? So when the problem looks like this, make sure you're looking at that. When it looks like this is the only time you're going to get rid of the denominator first. Get rid of that by multiplying by it. I multiply both sides by 3. -12 times 3 is somebody -36. Therefore, add 7 to both sides, and you get -29. Okay? We better see that again. This one. Notice the difference between the two that I just circled. Can you visually see a difference?
Maybe.
Right? This one has a very long fraction bar, 2 things on the top. This one has a little short fraction bar, 1 thing on the top. Only if it looks like this do I want you to get rid of the 6 first. On all the other cases, these 2, get rid of what's added or subtracted first. Hey, what's being added or subtracted? What's being added or subtracted? Help me out here. What's being added or subtracted?
-6.
So get rid of the 6 first. What's being added or subtracted?
20.
Get rid of the 20 first. Uh-oh, long fraction bar. What do you get rid of first? I'm going to get rid of the 6 first. This is the only time that's going to happen. Chris, when you're in class, where should your attention be? I'm just going to claim right now in front of everyone, if I had your attention the entire time, we'd be good, right? I've yet to look out upon the audience here and see you looking at the board. Do that. Trust me, it will help out. Okay? All right. So we're going to add 6 to the first one, this one. That's the answer. That's the answer. That's the answer for those that already did it. We're out of time. Okay. You have just enough information now to be very dangerous. All right. Let me hand out the test. All right, no one leave the room. Inside the room. Inside the room. Kristen. Wait. Come on, let's go. And plus I asked you to tuck your shirt in and start a class. You're up to 1.5 attentions now. Nathan.
That's high. What?
Piper.
I have.
Sierra. Not too hot, Sierra. Julie. Stop. I said no one's leaving the room until after I hand these out. Rowan. I was expecting more from you, Rowan, on this test. Caden. I don't know you well enough to say I'm disappointed or impressed, but you did pass. Sophia. Good job, Sophia. Anna. Anna got the second highest score. Ari. Brandy, I'm seriously impressed. That's crazy good. Riley, second high score. Good job. Yeah. Rylan. Yeah, that's a lot. Landon. Pretty good. Josie, silly mistakes. Porter, you passed. Hannah, no lots of silly mistakes. Kaylee, you passed. Same conversation we had before. Mike, good job, good work. Lily, not bad, a few silly mistakes. I don't know, Fred, calculate, figure out. All right, we made part. Yeah. So I'm just going to say, it needs to go same or different signs. That tells you whether you add or subtract, right? So then it goes add or subtract. So once you determine that this is good, but this is for multiplication division, right? Same or different looks like this, right? Yeah. But then you say if it's the same signs, you're going to, and different signs, you're going to subtract. So if that's what you mean, but you got different things.
Wait, the same sign.
If it's same signs, you're always going to add. If it's different signs, you're always going to subtract. Remember, this doesn't involve multiplication. This involves adding, subtracting. Haley, any questions?
Yes. What is the homework? I didn't.
Homework is, here we go. Oops, there you go. Good, Haley?
Yep. Got it.
Cool. Have a good weekend. See you on Monday.
Yep. See you on Monday.